Hi, it's power supply review time again, and we've got a pretty high-end bit of kit today. Not a big name brand, one of the cheapies, but that's the key. It is a precision triple output power supply. It's the Atten, let me get this right, PPS3205T-3S. And 3 independent isolated variable outputs, 0 to 32 volts at 5 amps on 2 of the channels, and 0 to 6 volts at 3 amps on the 3rd channel down here. Completely, there it is, PC interface. There's a USB and serial interface, and it's a precision supply. Forgive me, I'll hold it up, come on, I'm strong enough, jeez. It only weighs 10 kilos. Linear power supply, of course, precision output, 0.05%. So they claim, plus minus, 10 millivolts or something like that. So real precision bit of kit and a big graphic display on the thing, as we'll see. So the key to this is that it is half the price of probably the next one on the market that's equivalent kind of, triple output, high power linear precision one would be the Rigol unit. And it's half the price. I got this for about 450 Australian dollars. So yeah, pretty darn cheap for this class of instrument. Is it any good? Smells a bit cheap, but could be good value for money. Let's check it out. And here it is. And one of the first things you notice is that it is actually a quite compact unit. I mean, for the power we're talking about here, we're talking about 160 watts per channel, much less on the 3rd channel, but really quite a high power linear supply. As I said, it does weigh about 10 kilos, but really it's only 200 millimeters wide here, so it doesn't take up much space on your bench, really. And compare it with a multimeter, it's only like 2 multimeters width, something like that. It is quite small. It's about 350 millimeters deep, but yeah, not too bad at all. Now, yeah, it's got a carry handle on top. I will have to crack the thing open to see if it's actually sturdy or not. It's built like a cheap-ish power supply. Not as bad, doesn't feel as bad as many of the cheapies, but it's certainly not like an Agilent or something like that. So, really, you get what you pay for. And on the back here, nothing much happening. Standard IEC mains input, 5 amp fused, a fan, which is really annoying. We'll get into that. It is quite loud. It rattles. I don't like it at all. And USB and RS-232 interfaces for the PC control. And I believe they would be presumably isolated as well. We'll check on that. And on the bottom of the unit, 4 big sturdy rubber feet on the thing, and looks like big mounts for the huge monster transformer in there, as we'll no doubt see when we take this thing apart. I assume that they've got shake-proof. They don't have shake-proof washers on the bottom, but they might have them on the top side inside. So build quality is certainly adequate for the price, that's for sure. All right, let's power this thing up, and clunk. Atten Rev 1.0 software, be afraid, be very afraid. But there it is. It's got a triple output display here, channel 1, channel 2, channel 3. One of the things I don't like is that, like, channel 1, channel 2, channel 3 are identical. It doesn't tell you what the, it doesn't say this one's 0 to 32 volts, this is 0 to 32, and this is 0 to 6. Why doesn't it tell you that? I mean, you've got to know. If you just walked up to this, you wouldn't know that this one only goes up to 6 volts. You would have to know when you actually go in and try and type in a value in there to go up to 30 volts, and channel 3 can't do it. So, labeling, geez, it's not rocket science. Now, as for the display itself, it's not bad. Nice bright backlight if you're looking directly straight on the thing. If you turn it to the side, it does sort of, it does wash out almost completely if you move it out like that. Or if you go up, then it washes out, of course. And it does pretty good from below like that. So if you've got it up high on your bench, you can actually read it reasonably well. So, it could be better. It's not the best display. Now, what I'm going to do is peel off this protective coating here. It does make it look a bit a bit daggy. There we go. Ah, much better. Check out the quality control on this one, folks. Look, it looks like someone's like eyelash or something has been embedded behind the display in there. Someone at the Chinese factory. Hi, how you doing, if you're watching? Now, you can probably hear that. One of the first things you notice is that the sound of the fan is incredibly annoying. Yes, it does have a variable speed fan, which is great, but listen to it. Clunk, clunk, clunk. Not sure if you can hear that, but it really is not that great. Listen. And there you go. It just sounds awful. It sounds sick. Like there's something wrong with the thing. Just the bearings are shit. They use some cheap-ass fan in it. Urgh. Anyway, we'll be able to fix that up later, no doubt, with a fan retrofit. But you know, it's not too bad. They could have done more with the graphic display. Like, for example, if you only have one channel turned on, why not, you know, have an option for, say, a larger single display or something like that? But no, it's fixed. There's no power display. It's great that it shows the voltage to 10 millivolt resolution, current to an excellent 1 milliamp resolution, which is great, but they don't display the power per channel. That would have been kind of nice. You know, it's not the best laid out screen at all, so I don't know. You know, personal opinion. Big output button here. I like it. If you notice, whoa, over voltage. What? Over voltage protection. Fail. What's going on here, folks? Haven't seen this before. Over voltage protection in the channel 2. Please push Shift OV preset key to clear the OVP status and reset. Oh, well, there you go. I have never seen that before. Shift OVP preset. There we go. I get 34. There we go. 30 biggest channel 2. I don't know why is set to 34 volts. Maybe I was playing around with it, but why set it to 34 volts if it's not actually capable of doing that? Crazy. So feature-wise on the unit here, we've got, it's actually quite, you know, quite well equipped. It's got overcurrent protection, of course. We'll take a look at the OVP reset there is to reset the overvoltage protection if it trips. The overvoltage protection is down here, so you can set all each maximum output voltage for each independent channel, or switch it off if it goes over. You know, like if the power supply fails. Fantastic, you know, protection stuff you don't normally get on low-end supplies. We've got independent, parallel, and serial mode here. Auto is, it doesn't make sense, right? What's auto on a power supply? It's actually automatic sequence. So you can set up a sequence of events in this thing, and then you can run it by pressing the auto button. You can get into the comms. It's got recall and preset stuff, so various front panel settings. You can recall and preset those. This mysterious button called FC down here actually sets the digit. Believe it or not, sets the digit that you're using when you adjust the voltages here with the knob and stuff like that. Step is just, it actually just displays what you're stepping at. You can't actually set it. So, you know, I don't know why they dedicated a key to that. It's bloody ridiculous. You've got your output on-off button, which is combined, as we'll take a look at. You can actually switch the beep off. If you find that beep really annoying, you can go boom, like that, and it shouldn't, hopefully, beep at you anymore. It doesn't. Silent. Ah, there you go. And W resets factory defaults. You can adjust the contrast, and you've got some cursor keys to do stuff here. A lot of functionality in this thing, but convoluted layout. Now, when I first got this thing, it took me ages, because of course I didn't read the manual. Of course, you know, it's a power supply. You should just be able to walk up and use the damn thing. And it took me ages to figure out how to adjust voltages with the knob and set the on-off, the outputs on and off and independent like that. And well, let me show you so you don't have to go through the same grief. You can read the manual. The manual's okay-ish. But, you know, well, it could be a lot better, that's for sure. And the user interface could be a hell of a lot better, that's for sure. Now, if you want to adjust the voltage, at the moment, none of the channels are selected. So, if we press VSet over here, you know, we can't set the voltage, we can't set the current, we can't type in values, we can't use the knob. So, it's almost like an automatic key lock kind of thing, which is actually quite a good feature. You can't just accidentally bump it and you know, adjust your outputs accidentally and blow up your circuit. So that's pretty good. So let's say you want to adjust the voltage and current on channel 1. You've actually got to press shift channel 1 here, and channel 1 is now selected. So now, no, you can't just go in and use your knob like that. You've actually got to go VSET, and you still can't use your knob like that, folks. Hate not being able to use your knob. It's ridiculous. It took me ages to figure out you've got to actually press it, and then you're in knob mode like that. And yes, the output does change live, even though you just you press enter to sort of, you know, lock it in and go out of that mode, but it does actually change live, and I'll show you that. So VSET, there it is, jump in and you can adjust the least significant digit. As I said, this FC button here allows you to jump over a digit like that, and like that. You can't jump to the 10 volt digit, though. It doesn't let you do that, presumably because it's too big steps, and ooh, you might blow up your circuit because you don't know what you're doing. Dummy mode. Anyway, you know, as long as once you know, it's not too bad. You know, you can get used to that. Now, as I said, you can't just push the buttons like this. It beeps at you. If you want to type in a voltage, you've got to set 10.12 volts, enter, and it jumps to 10.12. Not a problem. And it's the same deal with the current as well. You go into current like that, you press that, and you can adjust your knob, and then you can go up in your settings like that. So it's not too bad, or you can just type in the value. And by the way, really annoying, like you can't just go 0.23, right? It automatically jumps to 2 like that. So you've actually got to go, same with the voltage, you've got to go 0.23. Geez, thank you very much. Okay. Oh, hopeless. You think it would just assume the 0. It's just little firmware annoying issues like that which just ruin the experience on this thing. And look what happens if we actually go into V here and we go into knob mode. No, it didn't recognize that press. And we're jumping around like that, and we just start typing in a value. Look, it's just put in 50 over there, like, you know, 5.00, so you can type on top, yet it's left all the garbage underneath. I mean, it's just, look, and it didn't even recognize that. It didn't even recognize that at all. I mean, it's just, why let you even do that? It's just madness. It's pure madness. You know, 10.12, look, enter, like, oh, and then now it accepted it. What? Oh, man. And yes, I'll state what everyone's thinking. It's typical of these cheap Chinese designed units. Nothing against China, it's just, you know, they can produce good products if they really want to. But these companies, they, you know, just get it working, and they don't put any thought into the user interface at all, and they build them down to a price. They, you know, functionality wise, spec wise, it's probably quite good value for money, and it's probably reasonably designed and built inside, but they always lack the user interface. They're just awful. So really, you know, they could have dumped the recall key, the independent key, the auto key, the overcurrent protection key, the overvoltage protection set, this FC button, and, you know, put those as shift functions somewhere else and had more usable dedicated keys on the thing. Ugh. And I'll show you that this knob does actually adjust the output live, because you may not believe it unless you actually try it. See, and it doesn't like tell you stuff like that, you know, in the manual. You just got to sort of try it for yourself. So we're channel 1 selected. Let's go in, voltage select, boom, and we can see it. There we go. We can see it jump up there on the meter. And of course it's bang on, as we'll check. But yeah, there you go. It does update live, and the enter is just to get you out of that mode and effectively go back into sort of key lock mode. And let's just try the parallel and serial mode. I've got it set to ohms here. As you can see, totally isolated between all the channels. You know, not a problem at all. So if we go into, it's not too bad that you got just that dedicated independent key just to go back, you know, just give me all independent channels. But on its own, you know, it's a wasted key. They could have used it for something else. But anyway, let's go into independent mode here. And you think you'd be able to use the buttons, right? You think you'd be able to use these cursor keys here. No, you can't, right? Like stupid. It's just like crazy. And you got to, and the knob only goes one way, right? It just goes, you know, I give up. This thing's hopeless. Anyway, enter. Let's go parallel. Okay, so these two parallel, by parallel and mode, it's parallel and serial mode only operate on channel 1 and channel 2, and it doesn't tell you that. So if we switch our parallel mode here, it should parallel these two channels up. This one is always going to be an independent, this 0 to 6 volt at 3 amp, always going to be an independent of these two. So it only operates on channel 1, channel 2. Would have been nice to tell you, but anyway, parallel, we should see them parallel up. And they haven't. Why haven't they paralleled up? We're in auto mode. No, hang on. Parallel out. Set. What the hell? Urgh. There you go. You've got to actually go out of bloody auto mode here, and you've got to go into independent mode, and then let's try that one more time for the dummies. Parallel. Boom. There it is. It's switched the two outputs in parallel. And if we try the series mode, we'll find that it actually shorts the positive and negative here as you traditionally would do, so that it can give you a positive and negative common ground output supply for op amps and stuff like that. Really handy. So we'll go down here, we'll go series, and bingo, there it goes. It just shorted those two pins. So that parallel serial mode makes up for the fact that you don't actually get one of those traditional short-in bars, and the fact that the positive and negative terminals aren't next to each other like that, because that's how you traditionally do it before. You slide a short-in bar across and you can short out the two. This one does it with relays inside. Nice and handy. I like it. And they've got two earth terminals, which they've marked ground, yeah, whatever you want to call it. So, you know, it's handy to have two. I mean, obviously you can strap, say, you know, that one. If you had them in series mode, then you could strap the two like that, or you could strap them side by side. They don't give you a short-in bar to actually do that, but most of the time you're going to use these things as independent float-in outputs. And yes, they are standard 19mm spacing. Not that handy on a power supply, but they've done that, and they've even done that for the ground as well. They've just standardized right across the front of that on the spacing. Now, as for the bind-in post input, you saw that they do have standard banana plug inputs, and at first glance they do look like reasonable quality bind-in posts, if a little small of course, but you get that with a standard 19mm spacing. But if you open them up, yeah, they do come all the way off. Great, so you can put you know, ring lugs over them and stuff like that. And they do have a hole in there, as you can see, to put your wire through like that. But one thing I don't like is that they don't have the full metal base on them, or on the back of the binding post like this. It's just a little small thing, but yeah, they're not the highest quality binding posts I've seen, but they're reasonable for the price. It could have been worse. At least they do have the hole that you can put your wire through anyway. Now, of course, what you pay the big money for on this thing is not only the PC programmability, but the precision of the thing. As I said, the specs in this thing are very impressive. Let me point them out. You can have a look at the data sheet for this yourself, but the voltage set accuracy specified at 25 degrees is less than or equal to 0.05% plus 10 millivolts, or plus 20 millivolts when the rated output voltage is greater than 36 volts. Huh? Doesn't sound right. It can't go to 36 volts anyway. Crazy. Oh, these jinglish specs. I don't know. But anyway, the current is also less than or equal to 0.1% plus 5 milliamps, or plus 10 milliamps when the rated current's greater than 3 amps. And of course, ripples are pretty good. It's less than 1 millivolt RMS over the 20 megahertz range for voltage, and less than 3 milliamps RMS over that same 20 megahertz range for the current. As well, temperature coefficient 100 ppm plus 3 millivolts. Here we go. I may as well show you here on the sheet. Readback resolution 10 millivolts as you saw, resolution on display, and 1 milliamp current resolution there. 2 milliamps if the rated current is greater than 3, so maybe it switches range there, or switches current measurement range or something there. The response time from 10 to 90%, less than 100 milliseconds. For rise and fall is less than 10 milliseconds if it's greater than 10% rated load, and temperature readback coefficient less than 100 ppm. So, you know, you're talking about a serious bit of kit when it's 0.05%, and that's what you're paying for. You're paying for the ability, when you set this thing to 10.00 volts, that's what you're damn well want, and that's what you expect. So let's check it out. The Fluke multimeter is a similar order, of course. I could get out my higher precision bench meter, but let's not gild the lily here, shall we? So channel 1, let's switch it on. In fact, oh, I switched all of them on. There we go. Look, you can accidentally do that sort of thing with this if you're not careful. I just switched all 3 channels on at once because I didn't deselect it. And by the way, if you want to deselect, it's not obvious. We're selected, no. There we go, we're selected channel 1 there, so now we're only operate on channel, no, look, it just switched them all off. What the frig? Are you kidding me? It just switched, I had channel 1 selected, you saw it there, and the output should just work on channel 1. But no, look, it switched them all on. What the hell is going on here? What, because it's in series mode? Maybe? Sorry, let's just hit that magic independent button there. Let's try it again. There we go. Now it seems to be working. Let's try that series parallel mode again. That's a bad bug if that's the case, because it switched on channel 3. I can understand switching on 1 and 2 at the same time. It has to. But to switch on 3, that's got to be a bug. So let's choose, okay, series mode. Okay, so we're in series mode now. And let's turn on channel 1. Output on off. There we go. It's a bug. So when you're in series mode, and presumably it'll do that in parallel mode as well, it switches on channel 3. That is ridiculous, folks. So let's select channel 3. No. Unbelievable. And that's the thing. Like, ever since I started using this thing, I'm always finding something new and stupid and something wrong with the firmware that doesn't operate the way you expect, or it's buggy, or it just, you know, beeps at you and does nothing because you're in the wrong stupid mode or something like that. It's just really incredibly annoying. Oh, God. Anyway, let's switch them all on. And, of course, here you go. There we go. We're basically bang on 10 volts there. So the good thing is its spec is actually better than the least significant digit there. So when you see 10.00 there, you can be pretty darn sure you're going to get 10.00 out of this thing. So let's go into channel 1 and set the voltage 1 volt. No, look, it didn't even do that. Look, 1 volt. Thank you. Look, it assumes that it's 10 volts. It's stupid. Why do I have to go 1.0? Look, what? 1.000 volts. You got to be shitting me. No, it's not letting me change this voltage on channel 1 when we're in series mode. It's not letting me. I should be able to change channel 1 or channel 2, and they should track. They should just track each other, and it's not letting me change this. Why? Unbelievable. Let's go to channel 2, right? I'm selecting channel 2 now, and let's go. Voltage set, 1 volt. It's not letting me set it. Are you kidding me? Channel 3. Can I change the voltage on channel 3? Yeah, I can change the voltage on channel 3, but I can't change it on channel 1 or 2 because they're in series mode. How the hell do you change the voltage? I haven't done this before. Bloody hell. Now, if you read the bloody manual, it says that channel 2 is the master. There we go. In series and parallel mode, channel 2 is the master. Channel 1 output automatically follows channel 2 output. Fine. Let's go to channel 2. Channel 2, there we go. We should be able to V-set, push that. There we go. We can now adjust it. But you saw it before. It didn't bloody well do it. And look, it's not automatically changing the digits on channel 1 there. So even though it knows it's in series mode, it's not going to change that. I mean, is that a feature or a bug? You decide, right? 10.25, and look, right, it hasn't changed it. In series mode, it's not a live output like it was, is it? Yeah, look, folks, we're in independent mode, series mode, okay? These are supposed to be tracking. It is not live tracking. Okay, look, it's live tracking on channel 2, which is the master, but it doesn't automatically live track channel 1. That is ridiculous. Look, if we switch it over, if we press enter, I bet you it tracks it. No, it didn't track it. It's supposed to be series mode. Are you shitting me? And I just used the keypad to do it, and it switched. Watch this, right? I'm on channel 2. Okay, so channel 2 is selected. I voltage set 10 volts, not a problem, it changes and it tracks, right? But if you use the knob, it doesn't let you do it. It allows you, it sets them independently. But that's got to be a bug, because it's not a feature, because you can't change channel 1 unless you go back into independent mode, change it first, go back in and learn. It's stupid. It's retarded. All right, let's try the same thing in parallel mode, and of course, there we go, we're bang on 10 volts there. All right, on both, because they're actually tied together. They're shorted by the relays in parallel. So, and they would load share as well. I'm sure, you know, there's internal load balancing resistor in there, and it balances out, not a problem. So let's go to channel 2, which is our master channel. Nice if you actually, look, you wouldn't be able to just walk up to this thing on the bench and start using it if you haven't seen it before. You just toss it in the bin. Because it's just, you wouldn't be able to figure out how to use it. It'd take you half an hour to figure out how to get the damn thing working if you didn't have the manual. Unbelievable. So anyway, let's get in there, set up. What do we want? VSET, right? Let's go 20 volts. There we go. Of course, it's not a problem at all. It's working fine there because it's parallel mode. So that independent mode, let's try, hang on. No, that's the keypad, sorry. Let's do this. There we go, it's following. Okay, it's live following now, but it's just reading back. So, well, of course it's going to be accurate when it reads back. There's a bit of lag there on the on that channel, 20.59, but okay, it seems to be working. So let's check out the accuracy difference in parallel mode as opposed to independent mode. I've set it for 1 volt there, and we're 0.9963. I mean, we're getting more down into the 0.05% plus 10 millivolts down in there. But let's now switch that to independent. Annoying. Channel 1, voltage set, 1, enter, 1 volt, 0.9964. Okay, so it's the same. Channel 3 is within spec. There we go, 0.88. It's just within the spec there. Channel 2 absolutely tracks channel 1. We're in independent mode here. 2, by the way. And yes, I have double-checked this with a second meter, and it's spot on, of course. I do keep my meters within cal here. And up at 30 volts there, yes, we are within spec, not a problem. Now, one thing that does work well on this is that the fact that when you actually have the outputs on, it displays the actual output current. But of course, when you switch all those outputs, if you switch the one output or all of them off, any combination, then it displays the set current, 1.5 amps. So let's check the accuracy of this. So let's connect it, and you should, to the current mode, short out the output, and you should hear the fan whoop, go up. You heard the relay switching there. There we go, 0.993. It's displaying 1.001, and it's set to 1.000. So that is within the current spec of 0.1% plus 5 milliamps, not a problem. And the second channel there, yep, not a drama. And let's try the third channel. There we go. Yep, all within spec. And we can get it to spark here, folks, because we are up at 30 volts, so yeah, now we're talking. Let's just abuse the hell out of this sucker and see if it survives. Woohoo! Not a problem. And there we are, we're bang on. Well, on the meter, and a little bit off on the displayed current there, but certainly well within published specs at 5 amp current there. I've switched it down to 1 volt, so we're not getting a huge, massive spark when we do that. There we go, 5 amps, and channel 3 should be 3 amps. Maximum 2.999, 3.016, all well within spec. Nice. And if we try it right down at 10 milliamps current, there it is. It's drawing 10 milliamps there. I've got it set to constant current, and of course, you know, it's going to be near enough. There we go. That's certainly well within spec, right down at that, and the display is spot on to the least significant digit. This one's 4 least significant digits out, but there you go. It's drawing close enough to 10 milliamps, so that's not too bad. I mean, you're right down in the noise and right down in the resolution and the noise of the specs, so to speak, right down at that bottom end of the range. But certainly not a problem. Now what I'm going to do here is I'm going to measure the noise performance of this thing, and I've got my Agilent scope here, bandwidth limited by the way to 20 megahertz, because that's a spec. It's very important. The spec says less than 1 millivolt RMS over the range. There it is, 20 hertz to 20 megahertz. Okay, so it's important that you put that bandwidth limit in. If you don't, you'll see the noise increase there, the peak-to-peak noise. So you've got to have that bandwidth limit on, 20 megahertz. The RMS, we're looking for less than 1 millivolt RMS, and RMS is the key. The spec is not peak-to-peak noise, it's RMS noise, and there it is, it's less than 1 millivolt. So it's doing the business, but look at this horrible output here. Look at this switching. We're at 5 microseconds per division, 3 divisions there, and we're looking at you know, around about 66 kilohertz switching frequency there. What is the issue here? Well, I'm not actually going to tell you. I'm going to leave that for a quick little separate video coming up. Okay, so that'll be a little aside video. I won't explain it here. But this noise is not coming from this power supply. And here we go. If we have a look at our noise performance here, we'll use our Rigol. We're on 1 millivolt per division there, and you know, RMS, like the RMS figure is the one we're actually looking at there, 700 microvolts or thereabouts. This is only for an 8 megahertz bandwidth. The probe is on ×1. Let's try and on ×10. And there we go. We can only go down to 5 millivolts per division on the ×10, but you know, we're down in the millivolt region. I mean, you know, I'm not going to muck around any further. It's good enough. That's at no load, by the way. That's on the channel 3 output at 6 volts. And it's about the same there on channel 1 on the 30 volt range. And just for kicks, we'll try this on the Agilent as well. There are the RMS noise figures there for ×1 probe there with an 8 megahertz bandwidth. So, not too bad. And here it is with the 30 volt 1 amp load. It's not switched on yet, so that's no load. And now load. There we go. Not a problem. So we are drawing 1 amp down there. 30 volts. Yeah, it is basically bang on to our power supply there, and our noise doesn't really change. Let's bump it all the way up, and our noise doesn't increase at all at 30 volts at 4 amps, but I set that for 5 amps. Why is it 4? Yeah, something's going on here, folks. We have been diddled. I've got this set. The current limit is set to 5 amps on this channel here. And you can see it, if I switch it off, there it is, 5 amps, but it just ain't, well, now it's delivering 5 amps, but it's gone into constant current mode, so maybe we're a swidgen over. Let's tweak that down. There we go, we're going up, and now it's delivering, it's trying to deliver 5 volts at 4 amps, 5 amps, sorry, 30 volts at 5 amps, but it's just, there's something happening there. So anyway, I'm not sure what's going on there, but let's just check the 5 amp ripple, and there we go. It's bugger all, really. So not a problem in constant current mode, but this thing's gone into constant current, so it can't deliver. I can't see how it can deliver its rated 30 volts, 5 amps, and that's only with one channel connected. Let's try channel 2. No, we seem to be getting the same performance. Oh, there we go, 4.9. No, see, it just dropped down to 4. What the hell is going on here? I'm setting this to 5 amp constant current, and it does not like that at all. And there we go, I just switched it down to 20 volts, and I heard the relay inside click, so it obviously went to another transformer tap, and not a problem. It's able to deliver the 5 amps, not a problem, at 20 volts, but it certainly can't do it at 30. So there's a limitation, there's performance limitations here which they're not telling you in the specs. I mean, there's no, you know, power load curves on this thing or anything, no power performance curves really. So yeah, don't take it at face value. And I've got channel 3 hooked up, and I'm trying to deliver 6 volts at 3 amps, but it's not having a bar of that. There it is, 6 volts, 3 amps, but it can't do that. Let's see if it can do it at 5 volts. Nope. If we have a look at our waveform over here, that's at That's at 3 amps, constant current mode, and that's 50 millivolts per division. So yeah, that's at 3 amps. Let's try 2.9 amps. There we go. Not a problem. So it really craps out if you try and get right near the limits. Right, so I've got my current up here set to, say, 2.9 amps. Okay, so it's trying to draw, it is drawing 2.9 amps, and it is doing it at 6 volts. So it is able to do that. And my current set down here, oops, 3 amps, current limit down there. So yeah, it's able to do very close to its limit there. And of course there appears to be a bit of discrepancy here, 5.91 volts. I mean, this is a precision load, this BK Precision 8500. It's 0.05% class as well, but it's dropped. That's just the leads I've got here. The display itself is actually measuring right on the terminals, and if we can confirm that with the meter over here, there it is, 5.997, so that's just a drop on the leads, no worries. Alright, now let's test its switch on performance. Going on channel 3, 6 volts, 3 amps, see if it overshoots at all. I've got the scope set up to single shot capture, so we switch it on. Boom, look at that transition. Ramps, perfect linear ramp, no overshoot at all, very clean, nice. And that's with a full load too, by the way, so let's try it again with no load. So we'll switch our load off here, let's reset this. Change our, switch our output off, switch our output on, and boom, look at that, there we go with no load. It's much quicker, of course. I didn't change the time base there at all, and ramps up, there's no overshoot in there. Oh look, there's a little, there you go, you didn't see that when you're, there you go, you zoom in, there's a bit of funny business happening there. That's with no load, so you know that might cause an issue with your system if that was a problem. So, there you go, that's noteworthy, definitely. So let's try, say, an amp. So, we'll set this to 1 amp, and, is it? No, I set 1 amp, boom. Okay, now we're set for an amp. Let's try that again. Output, the output is on. Alright. And there you go, that's for a 1 amp. Constant current load, by the way, which isn't the best. We'll do it again with a resistive, pure resistive load to see if that makes a difference. But of course, the no load had that funny business. So even with the constant current load, it's you know, it's pretty perfect. Okay, let's try that again. I've got a pure resistive loaded here. It's not a wire wound resistor. It's a 10 ohm load. So at 6 volts here, we're only going to get 0.6 amps. But let's give that a shot, shall we? And see what we get. There we go. We're getting that same business there happening at 0.6 amps with at 6 volts. But of course the most important thing is there is no overshoot, virtually no overshoot there. I mean, you know, there's a little bit, little half a bee's dick of overshoot there with a little bit of recovery, but yeah, that's, yep, that passes. Alright, let's try the same thing again. Got our 10 amp resistive load, 20 volts output on channel 1, 5 amp current limit, so it's only going to draw 40 volts. It'll only give us 2 amps on the output, but let's ramp that up, and well, we'll have to change that to 5 volts per division. Okay, we'll give it a go. Single shot mode, output off, and output on. Bingo, look at that. Nice and clean. I like that. Not a problem. That's a switch on for a 40 watt load. That's at 2 milliseconds per division, so that's taking 1 millisecond, so that's taking about 2 milliseconds to switch on there for 5, 10, 15, 20 volts, of course, for 40 watts at 2 amps output. Nice. Okay, let's try the switch off, shall we? Let's give it a go. Output, let's move our trigger up a bit. There we go. Now output, hey, there we go. Let's try that one more time for the dummies. We're on. And there we go. Clean switch off. Not a problem whatsoever. Now I know what you're thinking, this BK Precision electronic load has a bit of a reputation as a power supply killer, so let's muck around with the constant power and constant resistance modes. Here we go, I've got constant power mode set to 90 watts there. I've got 20 volts output, so it should give us just under the 5 amp current limit. So let's switch that on. No worries, 4.5 amps, not a problem. Let's see what the switch on performance is. And there we go, that's our load switch on. We're 10 millivolts per division there. 90 watts constant power mode. It only drooped about, 15 millivolts or thereabouts and recovered pretty quickly. Nice, and let's do that again, but switch off. Boom, there we go, not bad at all. And let's do the same thing again, 20 volts, but with my 10 amp resistive load, and bang, put it in there. Yeah, we've got some bounce there. That's my contact bounce, but not a problem. And I've got constant resistance mode set to 4.1 ohms, and it's, it's handling the switch on of that, no problems whatsoever. If I capture that on the scope, there it is, not a problem. Let's go really nasty and constant resistance mode, 1 ohm. So it's definitely, it's not going to try and draw, well, it's going to try and draw 20 amps, but it's going to be limited to, current limited to the 5 amps there. So, whoa, look at that. It's oscillating. Woohoo! Will it kill it? Will it kill it? I love it. Listen to that. How long should we leave that going for? And of course it won't do that if you simply short the output. It'll just go into 5 amp current limit. So that's a unique quirk of the constant resistance mode when the thing's trying to hunt to do the constant resistance. That load is quickly cycling and the power supply going, oh, I don't know what to do, quick, switch relays, panic. But there you go, to its credit, it survived that, and it's surviving just shorts on the output as well, 5 amps. Constant current, so it lives to power another day. Not a problem. It's not like that co-rad rubbish. And there you go, I got it on constant resistance mode again at 1 ohm on the channel 3 this time. 6 volts, there's no relays clicking, it's not changing transformer taps, so it's, there we go, it's just jumping in and out of that 3 amp, doesn't know what to do. 6 volts, 0.1, wah. And you can hear the fan just revving up and revving down each time it does it. Alright, now what I want to do is capture it jumping a transformer tap. So I've got it on 5 volts at the moment, and so there it is, 5 volts per division, and we'll jump up to say 20 volts, and we'll try and capture that. So trigger point's just above 5 volts, so we'll go voltage set, and we'll go 20, and see what happens when it jumps. There we go. Nice linear ramp up there, constant current mode, and no overshoot, nothing when it changes taps. Very nice. And we'll capture that again with a 10 ohm resistive load. So we'll go from 5 up to 20. Beautiful. Look at that. Hey, a little bit of funny business happening there. But yeah, it doesn't overshoot. That's the main thing. Let's try that again, just up to 30 volts. See what happens. Woohoo! Look at that. But it does actually recover. There we go. 2-step process as it goes through maybe a couple of taps there, through 2 taps and then up to the final 30 volt. So that was with a 10 ohm load. So at 30 volts that's jumping up to a 90 watt load. So let's try that again, but with no load, shall we? So we'll go back down to 5 volts and we'll jump up to 30 volts. Bang, look at that. Not a problem whatsoever. And what happens when we go back to 20 volts under load? Well, let's set our falling edge trigger there, and we're at 20 volts, and we've got our 10 ohm resistive load on there, drawing 2 amps, and let's go down to our 5 volts and see what happens. There we go. Nice ramp down. Beautiful. I think I'm getting the hang of using this thing. There we go. Look at that. Alright, let's see what happens when we go from no load into constant current mode. So let's capture that. Whoa, look at that. There we go. Let's try that again. Boom, look at that. So we had some bounce there. So Let's look at that. Yeah, that's probably some bounce from our contacts there. It's jumped down. That's 2 volts per division, so it's jumped down in voltage, of course, and then ramped back up. Let's try that again, but in DC coupled mode, 1 volt per division, so we can actually see the real drop in voltage. And here we go. Boom. Look at that. Nice and clean. And let's see how accurate the constant current mode is. Our constant current is set for 3 amps. Okay, we're currently drawing 2.995, 2.996, and of course the voltage hasn't dropped. And let's see if we get very close to that 3 amps, it should switch into constant current mode. Yeah, hang on. Yeah, there we go. Bang. Right on target. Now I've had this thing going on a decent load for about 30 odd minutes now. I've got 40 watts load on channel 1, I've got 120 watts load on channel 2, and I've got a 18 watt load on channel 3 here, and I've got my temperature probe, and the temperature around back, it's not coming out of the fan. I mean, the fan's going full ball, and we're only getting, you know, 37, 38 degrees or thereabouts out of the fan, so the thing really isn't getting that hot at all. Now what we're going to do is try and find where the tap voltage for the 30 volts is. So I'm ramping down 30 volts. Once again, I've got that full load happening on there. So let's wait for the relay click. And, oh, there we go. So about 23 volts. Let's go up. Yep, 23.2 volts is where that tap kicks in. And we should see that temperature go up, and we do, because it's now dissipating more, being a linear regulator. At 24.4 volts, of course, it's dissipating more power in the heat sinks. There we go, we're over 40 now, and I've just had it running for a minute, so that's going to climb up. So the temperature of the heat sinks and its final capacity before any sort of thermal cutoff comes in, if it does actually have that, then we should get that. You would have to stress it at the lowest point of each tap range, so it's dissipating the most amount of voltage drop. Well, it's got the biggest voltage drop across the pass transistor. So there you go, but it did actually go up in temperature as expected. And the next tap here seems to be about just under 15. Yeah, 14.8 volts there, and jumps back up at 15.2. And the bottom tap, about 7.6 volts. And by the way, there's one other thing that's noteworthy, is that after all these load tests, it's still within spec on its output voltage and output current. So yeah, drift doesn't seem to be a problem. Now, yet another confusing thing on this is the store recall mode. Now, you might think that that stores and recalls voltage and current settings for the 3 channels, but it's not necessarily the case. It has to do with this auto programming mode, and it's and the manual really doesn't explain it. It's ridiculous. Now, what it actually is, if you go into store mode here, then it gives you these various channels. Oh, we can't use the cursor keys there. We've just got to scroll through, okay? And it has to do with channel 1, channel 2, and channel 3. So the different settings. So let's go, say we want the auto sequence, set up the auto sequence for channel 1 output. Let's go into that, channel 1, and then it has these various storage options. And whoa, we can finally use our cursor keys. Look at this, folks. We can scroll around, and yes, it's got up to, I think, 15. No, what is it? No, heaps. 30. 30 are program steps effectively per channel. So we go up here, and this is the voltage and the current, and then the delay time in seconds. So we can set our voltage. You know, we can. I've already set it there at 1, and then we can set it to 1 amp there for 1 second. So we want that to stay in that mode for 1 second, and then sequence through to the next one. And then if you scroll through the list here and you go and highlight, say, the 3rd one, and you press auto, then that puts that little cursor down there, and I'm presuming it'll stop when it gets to that point in the program sequence. So it'll go through those 2 steps, but it doesn't tell you. I'm going to set, this is channel 1 only, so we're going to cycle through 1 volt at 1 amp, not that the current limit matters, we won't be using it, but you can set it up anyway, for 1 second. So then it'll jump to 2 volts for 1 second and 3 volts for 1 second, and should stop when it gets to the end of that point. So it should cycle through all 3 of those. Let's see if we can capture it. Alright, so we've stored our program. There it is. It's in there. Let's get out of that. And no, you can't recall it. Okay, what you got to do is all you do is you run it. Okay, so you put it in auto mode like this. There we go. We've got auto mode, and then you press the output button and all 3 channels will turn on. You don't have to individually turn them on, stuff like that. So you press it and we'll now find that channel 1 is cycling 1, 2, 3 volts. You can't see the set current because this is the displayed current, but bingo, there you go. And if you capture that on the scope, ta-da, folks, there it is. That's what we have. There we go, that's 1 volt per division, so it goes 1 volt for a second. Let's horizontal position that. There we go, it's reasonably accurate. So it jumps up to 1 volt, 2 volts, 3 volts, and then that ramp down is because we've got no load on there, so it doesn't ramp down very quick at all. That's the output storage cap. But there you go, it is cycling through, and it's continuously cycling through. And that's a good use for having the oscilloscope on roll mode. There you go, you can actually see it. That's 1 second per division now, and you can see it cycling through, and it's actually doing that in real time. So it works. There you go. That could actually be quite useful. And there we go. I've actually plugged on a 10 ohm load onto that, so it's drawing 100 milliamps, 200 milliamps, 300 milliamps, and as you can see now, when it falls back down, it falls back down very quickly. There we go, and boom. And now I've set up a sequence on all 3 channels. Woohoo! I'm an advanced programmer. Channel 1 is counting up 1, 2, 3 volts. Channel 2 is counting up 4, 5, 6 volts, all with 1 second intervals, but you can change the intervals to anything you like with 1 second resolution. So channel 3, we've got that cycling 3, 2, 1. So that one's cycling downwards. So there you go. That's actually a pretty useful feature, and you can program it, be it a bit archaically, through the front panel user interface. So once you know, not bad at all, but try and figure it out on your own. Ugh. And for the life of me, I cannot find a use for the actual recall button. Yeah, shift store, not a problem, but the actual recall button, whether it's in auto mode doing something, whether it's in out of auto mode, it's just, I don't know. I give up, and the manual doesn't help at all. And it really is a shame that doesn't let you store and recall popular settings for the front panel. I mean, for the channels, you know. Yeah, this auto sequence mode is great, but geez, where's some just basic functionality to, you know, preset some voltages? Now, one of the good features is over voltage protection set. So you press that and you can set up the absolute maximum voltage for any one of your channels. So let's say you had a real critical device under test, a real critical board on here. It's, you know, 3.3 volt rail, and if you went over that, you're going to blow the arse out of your, you know, your $10,000 prototype board or something. You don't want that to happen. Could ruin your $10 million project, the schedule for your $10 million project. Oh, right, and you'd probably get the boot straight out the door. So you don't want that to happen. So you can go in here and you can set, you know, I don't want that thing to be over 3.4 volts. And that is a separate protection circuitry, which ensures that there's no way that output can go over 3.4 volts, or presumably there's extra circuitry in there that allows that. If the power supply fails, it's supposed to be an independent, the whole idea is it's an independent thing that which kicks in, but may or may not be, you know, probably just done in software really, but still, it doesn't mean, it means that you can't do anything stupid to the front panel. Let's say we don't want that channel 2 to go over 3 volts. I've already got that for that auto sequence programming. Let's see if there's a bug in there. Right, so over voltage protection on channel 2, yeah, there we go. Notice, over voltage protection on channel 2, please push shift over voltage over voltage protection reset key to clear over voltage protection status and reset. So there you go. We have to clear that. Oh, there we go. We've cleared it, and channel 2, it's got 6 volts there, but let's see if we can switch on the output and actually get 6 volts. All right, let's press the output on, and nope, it protects it. Not a problem, and I'm checking on the scope over here, and no, it limited it, and it didn't jump up at all to 6 volts. Brilliant. But one really annoying feature is you can't just turn on channel 1 like that and have over voltage protection set on another channel, because it just won't let you turn on any of the channels. It's stupid. Protect that channel, great, but let me do whatever I want with the other channels, please. Now what OCP does, or overcurrent protection here, does is that instead of going into current limiting mode, if you hit the current limit, it'll just switch off the output. So let's give that a go, right? It's OCP is off at the moment, right? So I've got channel 1 set to 3 volts at half an amp. It'll actually attempt to draw more than that. So let's go output like that. There we go, it's dropped, it's gone into current limiting mode, okay? So it's current limited to 500 milliamps, but it's just continuously, like a normal power supply, is continuously current limiting. But if you don't want that, if you want it to shut off when it exceeds that current limit, easy, turn on OCP, and bingo, it just turned channel 1 off because we were over current there. So if we switch all of the channels, see, and if I try and switch it on, I briefly try and switch it on, it goes over current and just switches the channel off. That can be very useful depending on your circumstances. And I tried to get the USB serial interface working on this thing. Yes, it is just a USB serial converter, and it recognized it when I plugged it in and installed the FTDI driver and stuff like that. But the software, well, let's just say it's as shit as the user interface on this thing. Couldn't get it to work, couldn't figure out how to set the parameters to, it wouldn't connect to it. Complete fail. Not going to waste any more time on it. And it does actually come with a document which lists all of the serial protocols to talk to this thing and control it. So I guess the idea, write your own software if you want to do that. I'm not spending another second on it. So the verdict on the Atten PPS3205T 3-channel precision power supply? Well, probably a thumbs sideways, not a thumbs down, because, well, you know, I couldn't kill it. It does represent good value for money, I think, and, well, it ultimately does work, even though it's a pain in the ass to drive the thing. So because of that, the user interface stuff, cannot give it a thumbs up at all, but it does represent reasonable value for a precision 0.05% class. It met its specs, didn't quite meet the performance, the power performance on the highest tap on the transformer, but you know, hey, it still works. It works reasonably well. It's quirky. I would actually buy some of these for the lab as a joke, right? Stick them in the lab and everyone will come up to it. All the engineers come up, oh, look at this new funky triple output power supply, and just sit back and giggle as you watch them trying to use the thing and just give up and toss it across the room in frustration, because it really is frustrating to use. But once you get the hang of it, I guess it's going to be okay. I'm going to keep it here in the lab, use it. It'll probably become my main lab supply because it is so versatile. You know, dual 30 volts output, separate 6 volts, precision. I love the precision in it. It's programmable, and that sequence mode, pretty handy. Might come in useful for sequencing some things. So without the need to actually, you know, hook it up to a PC and actually control the thing. So not bad at all. Yeah, thumbs sideways. I don't know. Cheap Chinese user interface. Bloody hell. Anyway, if you want to discuss it, jump on over to the EEVblog forum. If you like these reviews, please give them a big thumbs up. Catch you next time.